Hello guys, welcome to Ramta Solutions and welcome to your grade 12 physical sciences. We are looking at your work energy and power and looking at its past papers. So the question paper that we are looking at is the one written in my beloved province, Bokone-Bophirima, the Northwest. Okay, so this was written in September 2023. Okay, it was written in September 2023. So now, let's read what this question is saying. A cyclist cycles up. Ooh, I want you to highlight this. A cyclist cycles up. So that means he's applying some force. All right. A cyclist cycles up to the top of a hill with a length of 10 meters. So remember, we said that here you are given one. This basically says you have an applied force. Okay, I don't know what it is. And he's cycling, or she is cycling up a hill with a length of 50 meters. So delta X is 50 meters, right, at constant velocity. Oh, interesting. Constant velocity. Okay, constant velocity. The force of kinetic friction that the bike encounters is 55 newtons. So friction is 55 newtons. The combined mass of the cyclist and the bicycle is 70 kilograms. So we will say the mass is 70 kilograms. The slope forms an angle of 13 degrees with the horizontal. Okay, cool. 5.1. By the way, we need to complete this question in 16 minutes. 5.1. Draw a labeled free body diagram to show all the forces acting on the bicycle when the cyclist pedals up. Remember, guys, to say pedals up says to you he's applying some force. Okay? A forward force, to be precise. So, 5.1, your free body diagram will look like this. Maybe let me use these guys. I want these two to be equal, honestly. Okay, I want these two, honestly, to be equal. Okay, so we will call this one the normal, and we will call this one, let's call it FGY. And then we also have, allow me to have it like this. And then I'll also add another one. This one, look too long, buddy. But it doesn't matter as long as you are shorter than this guy. Okay? Okay, as long as you are shorter than this guy. Let me redraw you. Okay, it's fine. So we have this guy. We will call him FGX, and the one shorter than him is friction. And this one here, we will call him the applied force. So even if you write just F only, capital F only, it's okay. Okay, so this applied force is the force that the cyclist applies in order for the bicycle to move up this slope. So this is your free body diagram. Remember, guys, your normal and the perpendicular component must be equal in height, or in length rather. Okay, perfect. Now, 5.2. When the bicycle is going up the slope, calculate the work done by the what? We're calculating the work done by friction. Okay, the work done by friction. 5.2.1. The work done by friction will be friction delta X cos what? Cos theta. So, what is the magnitude of friction? It's 55 newtons and the distance is 50. So 55 times 50 times cos friction opposes motion, so it will be cos 180 degrees. So let's see. 50 times 5 will be 250, and then 5 times 50, sorry, 50 times 50 will be 2,500, and then 5 times 50 will be 250. So this must be 2,750, but negative. Yeah, negative 2,750 2,750 joules. Okay, you guys have your calculators there. Maybe let me take mine as well. 55 times 50. Okay, it's 2,750. So this is the work done by friction. Okay, perfect. Now, work done by the gravitational force. This one is interesting, guys. Remember, with this free body diagram, you resolved your gravity, right? You resolved your gravity. This gravity does no work on the object, but it is this one that's doing work on the object. Which one? The horizontal component. So work done by Fg, I'm going to say Fgx is equal to, we still remember it's mg sine that angle of the ramp. What is it? 30 degrees. Mg sine 30 degrees, right? Mg sine 30 degrees delta x cos theta. The reason, oh boy, the reason why I did not say sine theta is because I don't want to confuse you guys. I want you to always add this angle of the slope. I want you to add it all the times. So to confuse sine theta cos theta, you know, a lot of times I see us doing that, and we shouldn't be doing that, okay? Even myself, I did that in my time. It's wrong. It means that if you have sine theta and cos theta, it means if you said 180 here, you must also say 180 here, because you said theta. They are not two different things. So to avoid that, say sine theta. And those that are struggling with this is how we got it. Remember, normally you have it like this. All right, let's say this is normal, and then this is your gravity. When we resolve it, it'll be something like this, and then something like this, or something like this, and then something like this. So this will be your Fgy, whereas this will be your Fgx, and this is that angle in question. Right, this is that angle in question, and this therefore becomes your 90 degrees, isn't it? This becomes your 90 degrees. So when you look at it, you're like, ooh, sine 30 degrees is equal to Fgx over Fg. Therefore, this means Fgx is equal to Fg sine 30 degrees. Let me move it. Right. So this means Fgx is equal to Fg sine 30 degrees. But what is Fg? It's weight. You call it mg, right? You call it mg. So this is mg sine 30 degrees. So if you struggle with breaking this down, this is how we got to this. Okay, so here is it. All right? Perfect. Now, let's see, what is our mass? The mass of the object was 70 kilograms. So cool. 70 kilograms times 9.8 times sine 30 degrees times the displacement is 50 times cos this is going in the same direction as the friction or its opposing motion. So it will be 180 degrees. Let's see. 70 times 9.8 times 0.5 times 50. Guys, please don't be confused. This 0.5 is the sine 30. Remember, sine 30 is half. Okay. So the answer that we are getting 17,150, to be precise, negative. So we are getting negative 17,150 joules. This is negative work done. Okay. Now, 5.2.3 says that we must calculate the work done by the applied force. Woo, interesting. Work done by the applied force. 5.2.3. Is that so? Yes, 5.2.3. So I will use the work energy theorem, 5.2.3. Net work is equal to change in kinetic energy. And remember, they said this bicycle is moving at a constant velocity. So since it is moving at a constant velocity, it means your change in kinetic energy is zero. So net work is made up of work done by the applied force. Let me call it, call it applied, plus work done by friction, plus work done by gravity, right? Plus work done by gravity. So we said change in kinetic energy is zero. Now, what is this? What is this? So we said work done by friction was, where is it? It was negative 2,750. And the work done by gravity, horizontal component of gravity, was 17,150, isn't it? So let me see in my calculator. I will say answer plus previous answer. So this gives me work done by the applied force is minus 19,900 is equal to 0. Therefore, work done by the applied force, is 19,900 joules. It is not surprising that this is positive. It is supposed to be positive. As you can see, it is in the same direction as the displacement. Right? It is in the same direction as the displacement. So now, let's see now. So the last question says, determine magnitude of the applied force. We know the work done by the applied force. So, we are good to go. So 5.3 rather, work done by the applied force is equal to applied force times displacement multiplied by cos theta. So what was it? Work done by the applied force was 19,900. What is the force? The force we do not know. It is what we are looking for. What is the distance? The distance, I remember it was 50. Now, this is going in the same direction as the displacement, so it will be 0 degrees. So this is 19,900 equals 50. This almost looks like 60. This is 50. All right, this is 50. Now, 19,900 divided by 50. In other words, answer divided by 50. Our answer is, therefore, the applied force is 398 newtons. Again, it is not surprising that the value is positive because it is going in the forward direction, which is the positive. So, for this question, we're supposed to spend 16 minutes at least. But if you say you were very slow, at least spend 18 minutes. If you find yourself spending more than 18 minutes, please move on to the next question. You are struggling with this question. Okay, so this is it, guys. This is how you got your 16 marks, or this is how you get your 16 marks. So, as you can see, we managed to finish this in 13 minutes, or even less than that. Okay, so with that being said, ours ends here, and goodbye.